Hey guys, this is the second part to the video. I've talked about your hardwired control unit, and this is your second method, your delay element method. We have seen your state table method. Please go watch that. Then only you'll understand this because that's the basis for this. So what is your delay element method? Okay, so basically it's your flowchart method. So what's going to happen is you're going to have your start and you're going to have your three control signals. So your three control signals, C1, okay, I'm keep on repeating your C1, C2, C3. This is your MAR gets PC, your memory gives the value to MBR, and your MBR gives it to instruction register, and in this two simultaneous independent operation happens, your PC increments. Okay, so these are the three control signals. So here I'm going to take a processor that can perform only two instructions, your addition and subtraction, just to give you a brief idea as to what is happening, then you'll understand. We can further modify it to give multiple instructions, but for now it's just either 0 or 1. If it's going to be 1, it's going to be perform your addition. If it's going to be 0, it's going to perform your subtractions. This is nothing but your 0, this is nothing but your 1. So it goes through all of these control signals because this is redundant. Okay, this has to be common for all of them. So this was the problem about the last method, was this was redundant. It kept happening continuously. Even though you had to multiply or add, you need separate circuit for that, but here it's going to be common. So this is why this method is much powerful as compared to the last one. So here what happens is you're having your three control instructions, and it's either perform your addition or subtraction, and then it write back, okay, and then it ends. So let's draw your equivalent circuit. So always building the hardware will give you a deeper understanding as to how this works. Hardware implementation. So yeah, so your start is nothing but going to be your VCC. Okay, so first it's going to give you C1, second it's going to give you C2, and third it's going to give you C3. Is this right? Because if you were to know your basic electronics, I'm pretty sure that if your C1 goes, your C2 will happen simultaneously and your C3 will happen simultaneously. Is that what you want? Can you fetch and decode and execute the instruction all at the same time? Of course not. It's not possible. So there has to be some kind of a delay between all of these three control signals. So yeah, let me just try modifying it. So what we're gonna have is, you're gonna have your, so just think of a delay element that you can use between these three control signals. Yeah, you're right, it's gonna be your D flip-flop. Okay, so for those of you guys who don't know what your D flip-flop is, so basically your D flip-flop will have an input and it's gonna give you same output. So if you're gonna give 0 here, you're gonna get 0 here but with a delay. You're gonna get 1 here, you're gonna get 1 here with a delay. And here again we're going to perform your you're going to give your delay element. And once you see here your decision box, so how your decision box is going to be implemented, just look at it carefully. You're going to have your, it's going to be basically your AND gate. Okay, so if it is yes, okay, it's going to give 1 1 here because it has already performed your C3 operation. And if it wants to perform your addition, just give your X. If it wants to perform your subtraction, give your X bar. So depending on that, your execution will be executed. Your operation will be executed. So once this has been selected, you're gonna go to your C6 stage. So let's look at your C60. So do you think this is right? See, here why we split it was because you had a common input to both of them, but you can't have a common output to both of them. Yeah, so this is not going to be right. Okay, so make sure you guys understand this. So what's going to happen is you're going to get an output from here or here. It's going to be an addition or subtraction depending on your X value. So there's going to be an OR gate, and then there's going to be your delay element, and then there's going to be your C6. Okay, so this is what, and your end, so it's going to go to your ground. Yeah, so basically if you see over here, your C3 comes over here between your C3 and your C4 instruction. There's no delay element. Yeah, so do you give your delay element over here? Do you separately give it over here, or do you give it over here? Of course you give it over here. You don't want to duplicate your elements over here, so try to be smart in that way. So let me get the eraser and let's try putting your delay element. So if you see, this is a really beautiful design that they have come up with, and you can clearly see how simplistic this full circuit is, and how it's making use of your redundant information and making it a common information for all of you this thing. So if you ask me the question, okay, see, you have done for 2 instructions. What about 3? What about 4? What about n number of instructions? So let's take your addition, subtraction, multiplication, division. All your flowchart is going to change is you're going to have your decision box. You're going to have 4 of them, 0 0 0 1 1 0 1 1. Depending on what you choose, you're going to have. Similar with the hardware, you're going to have 4 AND gates, and it's going to boil down to this. So this is the basic heart of your delay element method. So let's go over your advantages and disadvantages of this. So your advantage, of course, you guys must have already known that it uses the redundant information and makes it common, so it reduces your circuit complexity, and the speed of the process is definitely faster as compared to your other one, and you can include more instructions. So let's look at your disadvantages. So as your instruction increases, see, if your instruction increases, you can clearly see that your D flip-flops are also going to increase, the number of D flip-flops. Thus your cost is also going to increase. So this is one of the major disadvantages. So that's it with your delay element method. Thank you guys.